Hi friends! Recently I saw an AliExpress board on the basis of which you can build a boost converter from 20 volts to 220 volts. My attention was attracted by the fact that the board contains only one chip and a pair of FAT. Photos show the chip's marking wiped out. At first I thought it was some new development, but on the photos of another seller I saw that there is a well-known IR2153. The board is worth more than $10. And I decided to create a similar converter by myself. Didn't make sense to copy the Chinese PCB, because it is clear what that is, but isn't clear for what they put relay. It is here as a simple switch. Maybe it is for the remote control or soft start. Let's view the diagram. IR2153 is set to 50 Hz frequency to work with the network transformer. Inverter circuit is push-pull. It asks need the transformer with a midpoint. Trimmer R2 adjusts the frequency within a small range. Power FAT's IRF-Z44 could be replaced by the IRF-3205. Transistors should definitely be installed on radiators. When using a common heatsink, transistors have to be isolated from each other and from the radiator. Voltage to chip comes through the low power button S1 and diode VD2. Switch runs the converter and diode protects chip against reverse polarity. The scheme has no protection and stabilization. If not use the fuse F2, then in case of overload or short circuit, FATs will burn immediately. The output voltage can deviate from 220 depending on the supply voltage. With these components, the converter has 150 watts output. It could be increased if you connect in parallel several keys in each arm, and to add to the output a voltage follower circuit. By the way, the Chinese have released such boards too. Particular attention should be paid to the choice of transformer, since the diagram has not PWM control. Transistors are simply opened and closed. Power is not controlled. At first I used the transformer from UPS, which has 8 volts in each arm. This scheme worked, but no load current was about 1 ampere. That's a lot, shall not exceed 500 milliamperes for such schemes. Therefore, I advise to use transformers with a voltage of 12 to 16 volts in each arm. The secondary winding of the transformer is for 220 volts. Besides simplicity, this circuit has one more dignity. It is a wide range of supply voltages. It works from 8.5 volts. But I advise don't exceed 16 or 18 volts. In that case, you should choose another transformer. This is voltage at the gate of one of FATs. Filling is of 50% at a frequency of slightly more than 50 Hz. But, as already said, the frequency can be adjusted. In my experimental board, I put a fixed resistor in the frequency control circuit. This resistance is a little less than need, so the frequency above 50 Hz. By connecting the divider to the output of the transformer, we can see the output waveform. I assembled this experimental board just for demonstration purpose. I used a transformer with 20 volts, voltage in each arm and the power consumption of about 40 to 50 milliamperes. This is not exactly what needs here. Be sure to install a fuse F1 on the input. Another fuse F2 of 1 to 1.5 amperes advises to put at the output. I do not advise to use this scheme for serious purposes. In addition to the lack of stabilization, the output pulse shape is rectangular. You can connect any passive load, light bulbs, soldering irons, etc. You can feed devices with built-in switching power supply. I hope this was helpful for you. PCB and the scheme can be downloaded via the link below the video. There are also references to the Chinese finished boards. If you liked the video, don't forget thumbs up and share with friends. Thanks for watching. Have a nice day. With you was Akakasyan.